So it says here, in the last lesson, we talked about how many hours of Netbook students watch on average. This was per week. Now, a group of 6 students reported out the number of hours watched, and suppose that the mean number of hours watched for that group was 5 hours. So question 1, it says if the mean number of hours watched was 5, does that mean that each one of the 6 students must have watched 5 hours? And then it says why. So I want you to take a moment here on your own to go ahead and respond to question 1, just writing your thoughts down on your paper. If we think about the actual calculation for the mean, so that's adding up all of the values and dividing by how many there are, well, if we add up 6 different values and divide by 6, what would the numerator have to be so that the mean, or the average, ends up being 5? Have to be 30. And are there different ways that we could have 6 numbers add up to 30? Yeah, most definitely. I mean, certainly one option could be 6 values of 5 if they all watched exactly the same amount. But we could also have a little variation in this. Maybe this person actually watched 6 hours, and maybe this person watched 4 hours. So that would still kind of have an average of 5 between the two. Maybe we did actually have somebody with 5 hours. Maybe we had another person that did 3 hours, like 2 below. Another person did 7 hours, that would be 2 above. Maybe the last person did 5 hours. So this would be another possibility of 6 results that still adds up to 30, so that when we divide by 6, we still end up getting an average or a mean of 5. All right, so what I would like you to do here in part 2, it says with a partner, or you can do this with your team of 3, I want you to decide together on another possible set of 6 values that would have a mean of 5 hours. So I have given you 2 examples here. I want you to find a different example, a different set of numbers that would still have a mean of 5. All right, so we should have another possible set of 6 values here that would work. In part 3, it's now asking us to compare our list with another group of students, and we're going to find the range of each list. And that's going to help us answer the question of what list is more spread out. So let me show you an example here on mine. I'm going to look at my blue set up here at the top. The range is the highest value minus the lowest value. So for my set of 6 values, my highest was 7 and my lowest was 3. And so I'm going to subtract 3 from 7. And the range is just reported out as a single number, a single value. So my range was 4. So that's giving us an idea of how far spread apart are the values. Now, let's compare that to the initial set of 6 values where they were all reported out as a 5. Well, if we were to do that calculation for the range, highest value minus the lowest value, well, they're both 5. We actually would get a range of 0. So that's showing us, well, these values are really not spread out at all, which makes sense if you think about a dot plot. If you have a bunch of dots sitting on top of 5, they're really not spread out, versus if we have the other dots that show a little bit more spread. So let's go ahead and do part 3. You can compare your list either with the other pair of 2 within your group of 4, or if you're a group of 3, find another group nearby that you can compare your numbers. All right, so we take a look at this set of data and we look at the highest value of 8 and subtract the lowest value of 2. We see that the range for this set was equal to 6. If you have that different colored pen nearby or that you can grab out, we're just going to add a little note here off to the side in that different color for range. You can think of this as a formula for range. It is always going to be our maximum value minus the minimum value. And range is a measure of spread because it's giving us an idea of what's the full spread, how far apart are our data from the highest value to the lowest value. All right, so if we start to take a look at number 5 here, it says that finding range is helpful, but it does not tell us how spread apart the data is in between the minimum and the maximum value. So it can tell us how far apart it is from lowest to highest, but not so much about what's happening in the middle. So we're going to investigate this a little bit further. We're going to go through a process now that's going to help us to find the average distance of the values away from the mean. Now remember from Friday, the mean is a measure of center, so this is going to help to give us some information about what's happening inside of our data. So we're going to work through a set of steps here. So starting with part A, we are going to begin by finding the mean of our data. Now we're actually just going to use those 6 values that we had above in part 4. I'm going to actually re-list them off here so that we can view them on this screen. All right, now we know from what we looked at in the first part of the activity that the mean of this data is equal to 5. But if we didn't know that, we could just add these values up, divide by 6, and then we would get a mean of 5. All right, the second part of this process, in part B, we are going to find the distance that each piece of data is away from the mean. And we're just going to look at this one at a time. So starting here with the value of 2, the way that we're going to do this is we're going to take the actual data value and we're going to subtract the mean. So we're going to do 2 minus 5 to get the result of negative 3. So that's really showing us here that that value of 2 is just really 3 spaces below the center. All right, now we're going to look at the next data value of 3. And we're going to do the same thing. We're going to do the data value minus the mean. Well, 3 minus 5 is negative 2. So that value is 2 spaces below the mean of 5. All right, now what's interesting on the next one is that if we do the data value of 5, subtract the mean of 5, it's 0 spaces away from the mean. It is the mean. It's sitting right on top of the mean. So that's just going to be 0. If we look at the next value here of 6, and we subtract the mean of 5, now we have a positive result. That just indicates that that value is 1 space above the mean. We have another 6. So we're going to have another 1 space above the mean. And then finally, looking at the data value of 8, if we do 8 minus 5, we're going to get a positive 3. So that one there is 3 spaces above the mean. So I'm just going to write in my different color off to the side here that what we just did there for part B to find this distance is we did the actual data value and we subtracted the mean. And the negative results just indicated that the number was below the mean. A positive result indicated that it was above the mean, and if the result was 0, that means our data value was equal to the mean. So essentially, what we have kind of created here, these are like the individual distances that each value was away from the mean. Remember, our overall question is that we're wanting to find the average distance that these are away from the mean. Well, normally when we think about finding an average, we just add the values up and divide by how many there are. But something interesting would happen if we were to simply try to add our numbers up right now. The problem is that this exact number of negatives is going to be equal to that exact number of positives, just so that enough that they will cancel each other out, and we actually end up with 0. And we know that these data points are all not sitting right on top of the mean, so the average distance away can't be 0. And so we need to do something here in this next step to account for the fact that some values are positive and some values are negative. And so one way to deal with those negatives is to square them, because we know that a negative number squared will turn it to be positive. And so that's what we're going to be doing here in part C. So up above here, I'm just going to show if we were to square each one of those individual results, that's going to give us a new set of numbers here, 9, 4, 0, 1, 1, 9. So slightly different list of numbers here, but notice how now they are all positive. Now that the values are positive, we are going to find the average. So let's go ahead and put some plus signs here in between those little results. We're going to add those up for our numerator and divide by 6. And that result ends up being 4. Now let's think about what that number is telling us. That 4 is not actually the average distance each value is away from the mean. It's the average distance squared away from the mean. If we had units on these numbers, like if each one of these, well, yeah, we do have units on them. They represent hours. If these are hours, the units on these values would be hours squared. And so this result over here would also be hours squared. So what could we do with that number to get it back to regular hours? How could we undo the hours squared? We're going to square root, and that's exactly what we have listed here in part E. So we're going to go ahead and take the square root of that result there. The square root of 4 is 2. And this final answer that we've got after completing all 6 of those steps, we call this value the standard deviation. And that is answering the question of what is the average distance, or what is the typical distance that the data values are away from the mean? Well, on average, they seem to be about 2 spaces away from the mean. And so we're going to put that into a sentence down here in part 6, where it says interpret the standard deviation. And we're going to put the context of our problem into this interpretation. So we're going to say here that the number of hours watching Netflix for each person is on average 2 hours away from the mean of 5 hours. So for our interpretation, what we have here at the start would be the context of our problem. The actual value of the standard deviation is what we have listed here, and then notice how we also put in the actual value of the mean at the very end. That we saw this on Friday. One symbol for the mean is a little x with a little bar on top, so that's still a little something that we can think about for mean. All right, so standard deviation is the average distance away from the mean. Let's go ahead and turn over to the back to see if we can summarize some of the important ideas from today. We're going to continue with that quick notes box at the top. All right, so we had a couple of learning targets for today. So learning target number 1 was to calculate the range and standard deviation for a data set. All right, so the first thing that we talked about here for range is that it is simply the maximum value minus the minimum. or the highest value minus the lowest value. And we saw that the range is always reported out as a single number. So it would be appropriate to say something like the range is 4. What we don't want to say is that the range is from 3 to 7. So the range is not reported out as an interval. It's just an actual number. We just want to know the difference between those two values. All right, and then we also talked about standard deviation. And what standard deviation is just the average distance the data values are away from the mean. Now, learning target number 2 up here on the board says use a graph of a set of data to draw conclusions about standard deviation. So we're going to put in a couple of examples of what the graph could look like. So we're going to be looking at 2 dot plots. The first dot plot here is going to have a very low standard deviation. So I'm going to have a lot of data values that are clumped very close here to the center. The mean, the measure of center, is going to be kind of the center or the balance point of our dot plot. So I can see that the mean is probably somewhere around here. And the data values on average are very close together to the mean. So let's go ahead and put a label down here that this one would have a very low standard deviation. We're going to do another example here of a graph off to the side. Now this graph has some dots on the far end on both sides. Looks something a little like this. So the center, the average between the two, would still be probably somewhere where that little red arrow is. And notice how, well, the typical distance, the average distance away from the center for each data point is much further away. And so this second picture here would be something with a very high standard deviation. All right, now let's talk about learning target number 3. So up here it says, understand the effect of outliers on range and standard deviation. So if we think about what an outlier is, thinking back to our previous lesson, it's a value that's either much larger or much smaller than the rest of the data. And so an outlier, let's say it like this, outliers are either going to lower the minimum or make the maximum larger. So it's either going to be a very, very small value, making a small minimum value, or a huge, large value, making our maximum much larger. And so what that's going to certainly do then is increase the overall range. If we do the highest value minus the lowest value, and we have an outlier, it's going to make the range a whole lot bigger, because it's a bigger span from least to greatest. And if we think about the standard deviation, that's going to increase as well. Standard deviation is just the average distance from the mean. And so if we now throw in a value that's really far away from the mean, if you have a value that's a huge distance away from the mean, that's going to overall increase the average distance that the values are away from the mean. All right, so we're going to see if we can apply our learning today in the Check for Understanding problem below. So if you take a look at the Check for Understanding question, there are 3 dot plots for 3 different data sets. We're going to start off in the first part just doing some comparisons. So we've labeled these as data set A, B, and C. I want you to notice a few things about those data sets. Let me switch forward up to them. Here we go. So notice how the position of the dots are slightly different between them. Also, the way that the scales are labeled, the numbers that they actually represent, we're going to pay attention to that as well. So you're going to start by just doing some comparisons between what it's asking. And so in number 1, you're either going to use the less than symbol, the greater than symbol, or the equal sign to fill in the blanks for each one of those 4 situations. And then we have a couple of other questions for number 2 and 3. So I want to give you a little bit of time to work through those, and then we'll come back together and take a look at these before we leave today. All right, so we're going to come back together here and take a look at our 3 data sets. So question 1, part A of filling in the blanks, we wanted to compare the mean of data set A with the mean of data set C. Well, we know that the mean is a measure of center. It's going to be sort of the balance point between the dots on our plots. And both A and C seem to be very symmetrical. It looks like the center would be right here in the middle. Now, what's interesting about A and C is that we want to pay attention to how what looks like the x-axis, how that part is labeled, because it looks like the dots are in the same exact relative position. But the labels are different, and so the mean of data set A is 2, while the mean of data set C is actually 12. So this would be our first symbol there. C is greater than A just because 12 is greater than 2. Now for part B, the standard deviation of set A compared to the standard deviation of set B. So it looks here that B is going to have a greater standard deviation than A. If we think about the average distance that the points are away from the center, B has more points that are further away. Really, it's just these 2 points here from A are stacked up on the ends to turn it into data set B, and that slight further distance just for those 2 points is going to make it overall a larger average distance. All right, part C then is about the standard deviation of set A compared to the standard deviation of set C. These 2 are actually equal. Even though we have different labels here at the bottom, if we look at just the relative distance that all the values are away from the center, because those dots are in the same exact relative position between the 2 plots, their standard deviation calculation would be exactly the same. Because the data points on this far end are 2 spaces away from the mean. If you think about that in the calculation, over here, these values are also 2 spaces away from the mean. So it doesn't matter what the scale is originally, it's just what is that average distance, how many spaces are they away from the center. All right, and then finally we're doing the range of data set B compared to the range of data set C. Those are also equal, because the range of B is going to be the highest value minus the lowest value. So that ends up being 4. And data set C is the highest value minus the lowest value, which is also equal to 4. All right, then when we take a look at number 2, so this is getting at the idea of an outlier in this first dot plot that is just giving us dots labeled from 0 to 4. It's wanting to know what's going to happen if we add a data value of 12 all the way out here. So it's much higher than the rest of the data values. We want to know how that's going to affect the standard deviation. Well, we know that if we have an outlier present, the standard deviation is going to increase. So we can see here that 12 is very far from the mean. So the average distance from the mean will go up. Now we have kind of a similar question here for number 3, but the difference, look at the labels on the dot plot. So now, if we were to add a value of 12, 12 actually is the mean. 12 is the center. And so it's not going to be an outlier at all. It's right on top of a big stack of dots that are already there. So if you think about the calculation of average distance away from the center, well, this is 0 spaces away from the center. So it's going to incorporate another 0 in the calculation for standard deviation. And so in this case, the standard deviation is going to go down. It's going to decrease a little bit. All right, guys, hang tight here for just a moment before you leave. We have our Mohi Monday time anyway now. Okay, so final quick announcement here. This packet of our first 3 lessons, 10, 11, time 3, this will be due at the start of class tomorrow. So I've been giving you those suggested homework problems along the way. Hopefully you've been able to keep up with those. The final remaining homework problems that relate to what we did today are up here on the board. They're posted on Schoology as well. And so what I'm going to be looking at for your packet, you are going to earn 30 homework points for this whole packet. You are going to get 5 points for the completion of each of our 3 lessons. The other 15 points are for all of the homework problems being completed. So there's nothing extra in addition to what's in the packet. Just make sure that you have everything completed and ready to go, and we'll turn that in at the start of class tomorrow. For our Mohi Monday time, feel free if you want to stay seated in here and continue to kind of work through the packet, or if you have any questions for me. Otherwise, have a great rest of your day, and I will see you guys tomorrow.